Hello, my name is Dan Hall and welcome to episode 5 of Calibration TV. The topic of this week's episode is automation, and I hope to show you how we can get your equipment to do some of the work for you. For most calibration groups, the number of calibrations they're responsible for grows every year, but there's not always the resources available to hire the technicians that are needed to do all the work. I'm sure that sounds familiar to some of you. In some cases, implementing some form of automated testing can be the difference between getting the work done or pushing out your calibration intervals. As most of you know, calibration is a very repetitive process, and if we had to break it down into its simplest terms, we can describe calibration this way. Number 1, provide a stimulus to the device we are testing and a reference device. Providing a stimulus for a temperature calibration, for instance, would be putting our temperature device in a reference probe in a liquid temperature bath or a dry well. We want to make sure both devices see the same stimulus, or temperature in this case. Number 2, wait for things to stabilize. It's very important that both devices have reached stability and aren't trending anymore. So in our temperature example, some probes have longer time constants than others and take longer to reach the calibration temperature. Number 3, take readings from our test device and our reference. Sometimes this might involve averaging data over a period of time if our readings are a bit noisy or unstable. Number 4, go back to number 1 and repeat with a different value of the stimulus, such as a different temperature for the liquid bath. Obviously, a full calibration of a piece of equipment involves much more than just taking data at various points. We have to determine if the unit is in or out of tolerance, and there might be adjustments involved. However, the process that I described is what you typically do when you're collecting as found or as left data. And if we could automate just that process, we could save a lot of time, especially if changing the stimulus is time consuming. In the temperature example I discussed, changing a liquid bath from one temperature to another could take hours for stability. So in order to automate this process, we need, number 1, a way to automatically change our stimulus to different values. Number 2, a way to automatically read the output of our test device. And number 3, a way to automatically read our reference device. When you hear the word automatically, we tend to think computer, and yes, there are quite a few software programs available that will help us automate the calibration process. The most popular is probably Fluke's MetCal, which is used primarily for electrical calibrations, but there's also Fluke's MetTemp2 for temperature and Compass for pressure and flow calibrations. However, it's definitely possible to automate some portion of this data collection process without using a computer at all, and in this week's video I want to show you a great example of that. In episode 2 of Calibration TV, I introduced you to the Fluke 2271A Industrial Pressure Calibrator. This unit is part of a growing number of devices that help us satisfy all the criteria we need to automate our calibrations. It can automatically change our stimulus because it's an automatic pressure controller. It has an electronics module to read the output of our test device, if that output is either current, voltage, or heart communication. And the plug-in pressure modules act as our pressure reference value. The 2271A also allows you to set up and store built-in tasks. A task is a sequence of pressure points along with some information about the test device, such as the range and the accuracy specifications. What I really love about the 2271A is that when the automated calibration is complete, it creates an Excel file with all the test data that you can easily transfer to a computer. Take a look at this video. We've got 2 pressure modules in here, a plus or minus 15 psi gauge and a 0 to 100 psi gauge. These are PM200 modules, which can be used in either this unit or the Fluke 6270A pressure controller. I've got a Rosemount 1151 smart transmitter up here, and I'm actually connected by heart to the 2271A. Now, for purposes of this demonstration, it could be just a regular 4 to 20 milliamp transmitter. It doesn't have to be heart. The same tasks that I'm going to show you could be run. We're connected to the electrical measurement module, the EMM over here, and it just takes 2 wires to connect to the heart loop on the unit. There's an internal 250 ohm resistor, so we don't need any external hardware in order to do that. So I'm going to zoom in a little bit closer on the screen so you can see what's going on. We're going to run through a task, an automated task, and then afterwards, and we're going to do all this without a computer. So this is automation without a PC connected. Afterwards, we're going to connect up a computer and pull off the data file, and I want to show you how that works as well. So let me move the camera and we'll talk about what's going on the screen. Okay, we've got our transmitter connected both electrically and pneumatically to the 2271A. What I'm going to select down here now is the Tasks menu. And these are a number of different types of tasks that you can set up and store inside the 2271A. I'm going to go over to the Transmitter section and pick Transmitter Tasks. And as you can see, I've set one up here for Calibration TV. The range of this transmitter is 0 to 30 psi, so we're just going to do some 20% increment steps on the range of that unit. So I select Calibration TV and pick Run from down here. I put in a ID or a serial number of my unit under test. I've picked serial number 1234, the default for anybody who's trying to do something quickly. And I just put Continue. When I do that, it goes into automated calibration mode. So what it's going to do first is it already took our 0 value, our atmospheric value, took the reading of the transmitter. Now it's going to 6 psi, which would be a 20% increment on a 30 psi full-scale range. You see right here on the screen it shows 0.2 of 6 it's doing right now. And once it gets a ready indication, which is in green up here on the screen, once it gets a ready indication, it waits 5 seconds, and you'll be able to see this countdown timer. It says 0 of 5 right now. Once we get a green indication, it's going to count down for 5 seconds, grab the data point, and go to the next value. So I'll tell you when it turns green or ready. You can see it up at the top of the screen. Became ready. Now you see our timer here is counting down 5 seconds, grabs the data, goes to the next point. 18 psi. So we're coming up to the last calibration point here, 30 psi, which is the full-scale range of this 4 to 20 milliamp Hart transmitter. And we're stabilizing at our 30 psi point. After we get the green ready, there we go. We count down 5 seconds. When the test is complete, it pulls up this table that allows you to review the calibration data, all the data points and what the results were, whether they passed or failed the UUT criteria that you put in. But notice down here there's a note that says test results saved to a CSV file, comma separated value file, see the operator's manual. Turns out it was very easy to be able to import this into a computer. So over here, I've got a screenshot of my laptop computer. On the back of the 2271A is a USB port. The connection looks just like a printer port, and I've got a simple USB cable. I'm going to plug into my laptop. And when I do that, it pops up this window, which is the 2271A looks just like a flash drive. And on here are 2 Excel files for 2 calibrations that I performed today. If I click on these, it will actually open Excel right up. And now I have an Excel spreadsheet that has all of my calibration data that I just performed. And if I increase some of these columns, you can see each data point is time and date stamped. I've got the name of the test, whether it was milliamps or pressure, what gas source I used, my UUT ID or serial number down here, the tolerance that I had for the unit, which was 0.1% of reading, and down here is my calibration data for the test. So without a computer, obviously I do have a computer here, but the computer was not running the automation. I was able to fully automate a test of a transmitter, and afterwards, so you could do this to a number of different transmitters, save them in internal memory, and when I'm all done with my calibrations for the day, I just plug in the computer, copy all these Excel spreadsheets onto the computer, and I have all my data. I could have a second worksheet behind this primary worksheet that would be a formatted calibration certificate with logos and all of that information. So there is a quick introduction to the basics of automation. Since this is a big topic, I want to continue it in the next few episodes. Next time I want to show you an example of a simple automated temperature calibration using a very versatile and affordable product from Fluke, the 1586A. That video will highlight another huge advantage of automation, and that is calibrating multiple test devices at the same time. One quick update on the 700 HPPK high pressure pump from our last episode. I mentioned that if you order one of these from my company in February or March, I will include a free Apple TV with your order. It turns out that Fluke has also started another one of their promotions called Measure of Innovation, and the 700 HPPK is one of their qualifying products. So you can get 2 bonuses when you order from Hall Associates. One other quick reminder, my company, Hall Associates, is a distributor for some of the best brands in the calibration business. So if you're in the market for any new equipment this year, I hope you will give me a call directly to discuss your application. Your business helps support and fund the show, so many thanks to those who have called from all over the country. We haven't had a giveaway in a few episodes, so let's give away some swag. I'm working hard to get the word out about Calibration TV, so here's what I would ask this week. I bought some of these very nice Fluke work gloves. I have 10 pairs. All you have to do to be entered is to share this episode. You can forward the email announcement to your coworkers, but remember, you have to copy me so I know that you shared it, or share my post on LinkedIn or Facebook. That's it. I'll select 10 people randomly and get your mailing address and send these out. Sound good? So that's it for episode 5. I'll be back in a few weeks with part 2 of our discussions on automation. Thanks for watching and for sharing.